Hello and welcome back to another coding session with Mr. Jacob. In the last session, we experimented a little bit with Puppeteer and a Docker container with a Chromium in it and controlling it via a really simple Next.js application, which we simply use to scaffold quickly a TypeScript, Node.js web server environment thingy there, and took a screenshot from a specific website via a web request from our side and just got back the rendered image. And that worked out quite well. And we created actually something that we called a browser pool quickly, which we simply implemented in a way to have multiple pages maintained and a browser open once it was requested once. As a test to see if we can speed up things a little and if we can get into the timing range that I need for the project that I want to actually go on or develop on. And that was a nice experiment, but I discovered that I wanted to do something like I wanted to add some sort of queuing there because I needed to restrict the implementation to only have a certain amount of pages ready while they are given out, while they are being processed, and not have an unlimited amount spawning over and over and over again if there are too many requests at once. So in order to create some sort of backpressure in the system and not have this one system collapse under all the load that we create on it by spawning pages and pages and pages and pages if there are hundreds of requests in parallel, we need to kind of process those things in a queue, and we need to lock certain pages while they are in the processing and then free them and give back the other ones. And while I could implement that directly here in this browser pool, I was thinking about something like, can we do this in a general way? And that's something that I want to play around with today. I want to implement or try to implement some sort of asynchronous mutex in JavaScript, or TypeScript to be better said. Just to see how one could do that. I actually never did that in that general form, and I think I have an idea about how to do that, but yeah, we will see. And I guess we will try and implement two things. We will implement first a generic mutex for one value, one resource, which we can lock and release and get in line to retrieve such a lock. And then we might implement, that's what we will need here actually, a mutex collection, so to speak. So something where we can actually get in line to get one of the next 3 items of a list of the same type, so to speak. I'm not sure, maybe we will even be able to realize that using the mutex implementation, but I'm not sure. And as I've said, this is just me playing around currently with a couple of ideas, and this is an idea I got there. I don't really need that specifically for that project, but I wanted to have some fun trying that, and why not let you participate in that. So let's go ahead and implement something like a mutex TS, and let's see how we can actually do that. So I think what we first of all need is some sort of mutex class, something that we can actually instantiate, and that is templated over a type T, which can be anything actually. And we will actually have a public constructor here, which takes a value of type T, which would be the initial value, and I think we will store that as a private here inside the class. And we will see what we need then. Let's first kind of scaffold out the public API of that thing before we then think about how to do that. We will need something like a public function to acquire the mutex, the lock. We want to acquire the lock on this mutex here. So this will most likely return, not the value T. We need some sort of wrapper. At least that is what I'm thinking about. We need some sort of wrapper around our mutex value there, which we can then use to keep track of this thing and release it if needed. So I think we will simply return a lock on type T. Yeah, that kind of makes sense. And this function, of course, has to be async and return a promise of a lock of type T, because it could be needed to wait on that lock. Because if something else has already acquired that lock, we want to wait until it has been released there before giving it back here. Okay, so that is kind of the API that we need to implement here. So we need to have something to do here. And the question is now, do we have a public function which is something like release here, which takes a lock maybe? I'm not sure. If we have a lock type, I guess I want to have first define this lock type. Maybe we can have actually the release function on the lock type. I think that would be a little bit nicer. So let's define an interface. Let's export that interface as well, because other parts of the application will need to see it as well. So we have an interface called lock over type T. And I'm not 100% sure yet what data it will store, but we will definitely need then something like a function there which gives us the value, I think. So we need to be able to access the value. We will need something like a release function here, which I think simply returns not void, but void, which will be able to release this lock then, which kind of need to make this lock then invalid. So this lock cannot access the value unintentionally anymore. And yeah, and I think that would be the interface of the lock. So how would we actually implement something like that? We could, first of all, create something like this lock. What I want to do is I don't want to allow the lock to... Do we want to be able to actually replace the value? Do we need something like set value, new value T in here? Or yeah, something like that. Get the old value, set the new value, something like that. Do we need a function like that? I don't think that... Yeah, otherwise we would have a read-only mutex. This way we would have a read-write mutex, kind of. So I think there is no problem in simply having that feature, even though we might not even need it. But we are trying to implement this in a generic way. So why not? So okay, let's have this in the interface. Okay, so now let's think about how we actually do that, how we are going to do that. We need something here which actually checks if there is already a lock given out. So what we definitely need is something within our mutex which keeps track of the current lock. Yeah. So we need something like current lock, and current lock is either a lock over T or it is undefined. And we can then check here. The first one is the easiest condition, I think. If this current lock is undefined, then we can kind of return this create lock, or maybe this just lock. Yeah. We will have a function here called lock, and we will simply return a new lock here. So we will lock the value down and we will return that value. So let's see, where would we put that function? It would be somewhere here. It would be private. It would be lock. And it will return a new lock over T. That makes actually sense. Maybe we want to do the current lock setting here. Yeah, I'm not 100% sure. We definitely need some sort of function called unlock as well, because we need to somehow make this the reverse of this. But for now, let's see. We could implement this lock as a class, I guess. we could implement a class that actually implements this interface. And then we could return that here. However, then we wouldn't be able to access private stuff within our mutex. And I want to hide all the data as much as possible. So the question here is, I could realize this maybe using symbols. I'm not sure if this is actually possible. Let's see if this is possible. Maybe we can actually make this export class. However, then you could actually create a lock from the outside. I don't actually want that. I want to export an interface, and then I will have something like class inner lock, or let's call it lock impl, which implements lock over t, and it will be a lock impl over t. And we can then implement all the corresponding values, methods here. Okay, so now we have this public here, we have this one here, and we have this one here. Okay, so we now have some sort of class that we can then create here in our lock function. So what I would do here is now something like this concurrent lock equals new lock over t, and we would give it the would we give it the value actually? I don't want to actually copy the value somewhere if it's not passed by reference. So essentially I want to somehow access the value inside the mutex. So I think I would give this one the mutex itself. Does that make sense? Yeah, that may work actually. Let me try and think this to the end. It might work actually. So if we have a public constructor here, which takes a private mutex t, which has the this one actually has the reference to the real mutex here. Then how could I access something within this mutex? I cannot access private members then. The value here is private that we store here. So how will we actually do that? We could try to do that via a symbol. Okay, let's see. Maybe we can actually do that by just creating something like value symbol here, and we will simply create a symbol here with a name value. And what a symbol actually is in JavaScript is you can use this as a one-time identifier value for mostly anything, and but you can only access this property then in objects usually if you are not doing some sort of iteration over all the keys and stuff like that, if you have that symbol, so if you have that reference. So what I could do actually is I could I'm not sure if this actually works, but let me see. Can I do something like public, or no, let's wait, what? Public, no. Let me undo that. Let me store the value as a private here. And let's create a function, a public function, and I'm not sure if I can define it that way. We'll see in a second. Can I do something like, how did I call it actually? Value symbol. Let's call it get value symbol. So get value symbol, can I do that? And this would return actually t. Is that, okay, so can I actually do now this value here? Okay, it seems that I can do that. So now there is a public method on that mutex, but it can only be called by someone who has this get value symbol. And currently only everything that lives within this file has access to that get value symbol because we are not exporting it. So that's essentially something in the way of we created something like a friend class there now, which JavaScript or TypeScript doesn't have. But that's kind of, at least in terms of the value. We of course need something then, we have implemented set value, so we would need something like set value as well. Let's for now do that. Let's do set value, and let's do a set value symbol here. And let's create a public function then, which is set value symbol. And it takes new value t and it returns the old one. So const old value this value. And then we would do this dot value equals new value, return old value, something like that. Okay, so now we have that there. So essentially what this could do now is this should be able to do something like this mutex get value symbol, and should be able to call that. A function whose, wait, what? A function whose declared type is neither undefined, void, nor any must return a value. Oh, I simply missed the return before this. Okay. And set value would then actually be return this dot mutex set value symbol new value. Okay, this seems to actually work. And I think we might do the same thing with release, so that only a specific lock can call on its assigned mutex the corresponding release function. That's actually something nice. Then we would have something like, or let's call that unlock symbol, which is a symbol and it has unlock. And then we could do something like this dot mutex unlock symbol, and we call that and we give it ourselves so it can actually check if it's unlocked with the right thing. Yeah. Okay, that may make sense. We will see in a second. So if we have now a public function here, a public function which has this unlock symbol, and it takes a lock, which is a lock over t, and it returns void. Let's see. Then we can do something like if this current lock does not equal the lock, then something really bad happens. Then we have some stay lock or some lock that is not assigned to this mutex or anything that should be there, that shouldn't be there. So let's throw an error in this case, and let's do something like the lock given to free does not is not currently locked or assigned to this mutex. Something really strange happened. Because this should essentially never happen. If this happens, we have a definite bug in our code. This should not be able to happen if everything goes to plan. So, and otherwise, we would want to do something like we want to set the current lock to undefined, because now we don't have a lock anymore. And what we want to do somehow invalidate the lock itself. So we kind of need to tell the lock somehow that it is no longer something that might actually access the value. So maybe we could do that by having it give the lock in each of the set value and get value symbol things. And in this situation, we can actually do the same check. So if a lock is not the current lock, then it might not be valid. This here can actually happen if you call release more than once on a lock. So maybe a lock should know if it is released or not. That actually would kind of make sense, so that if you release it twice or 3 times or 4 times or 23 times, it would simply do nothing because it is already released. Yeah, that kind of would make sense. So no, we could do something like, could we have something like a private is released here, which is a Boolean simply. Yeah, that kind of makes sense. And it is initialized with false. And each time we do this, we can check that before. So if this is released, throw new error. Can't access value from released lock. And we simply do the same thing here. Can't read value from, and we can't write value to released lock. So this will not work, and we of course need the corresponding if here. Okay. So if it's already released, and if this is released, in case we are calling release, we will simply return because it is already released. And what we will do is, before calling the unlock symbol, or we need to think, do we need to do this before or after? I should think we do it before, because this might trigger, or this most likely will trigger something asynchronous, so in the background. So let's do is released equals true, so that we have a kind of atomic operations chain there. So now, in the moment this has been triggered here, you cannot access this lock anymore. It is released now. Okay. That actually kind of makes sense. The question is now, we could now return a lock impl over t here. And we then return this current lock. And when we return this, okay, if this current lock is, now we actually should have the case ready where we have something that is not, where we don't have any lock set yet. We are the only one locking something there currently. But now we actually don't need this to do anymore, because this happens automatically. No, wait. Yeah, it does. It happens automatically because it happens within the lock. Okay, that makes sense. So the question here is, if we are trying to acquire a lock on our mutex where already something else is holding the lock, then we need to somehow wait for this one to be released. So essentially we need to wait until unlock happens, and then we need to provide the next one in line, so to speak, the lock. So how would we do that? I think we will need some sort of queue here. So let's do create queue, which actually is, it's more or less, it's just an array of, of what actually? We need to be able to create a promise that we can later on resolve. And in order to do that, we need to be able to have something something like a deferred, which we don't have currently. So let's quickly create one. That's actually something that I have mostly in in nearly all of my JavaScript projects somewhere. So what we want here is we want to export interface deferred, or let's make it as a type. It's easier. Deferred type T over type T equals, it's just an object that has the following. It has a value called promise, which is a promise over type T. It has a resolve method, which is over type T. Which takes type T as a value. Yes, and it has a reject method, which takes a reason, which isn't any type. Yes, yeah. And cannot find name value. Oh, yeah. Okay, I need to do this the other way around. Which leaks return type? Yes, this one returns void, and this one returns void as well. So that's our type actually. And then we have something like export function create deferred over type T, and it will create us one of those types, which will allow us to have a promise that we can then resolve or reject from the outside. And that's a little trick I usually do there by simply doing something like we can now define a deferred, which is a partial deferred for now, because we can only later on fill it with stuff. So this is a partial default, and it will simply have a promise which is undefined for now. It has a resolve which is undefined for now. It has a reject which is undefined for now. So we are starting out with an object which is undefined. Then we are doing something like const promise equals, and then we are simply creating a new promise, and we are giving it the initializer function with a resolve and a reject parameter. And what we are doing then here is we are simply taking everything that we got there, like the resolve and the reject, and put it into our deferred object. So deferred reject equals reject. And then after that, we are simply putting the returned promise into the deferred as well. And then we can return our deferred as finished deferred over type T. The promise unknown is not assignable. Yeah, because we need to create the promise over type T here. Okay, so this essentially uses the fact that if you create such a new promise, the function within the promise, the initializer function here, wait, there should be a new somewhere. Promise like, okay, promise constructor like there. The executor function. The executor function is actually called directly. The executor function is called synchronously on a promise, and then everything that happens around that, when you do then a reject or resolve or something like that, that is happening asynchronously later on, because you can do that at a later point with a callback or something. So the executor itself is synchronous. So that's the reason why we actually can do something like that here and have this encapsulated and nevertheless return it to the caller. So this actually should work. It usually works. So let's go back to our mutex here. So what we now need is we need something like a queue, and we need something like a queue of didn't I just define queue somewhere? Have I removed it again? Okay, it seems. So, okay, so this will be now, did I know? Oh, interesting. Puppeteer core has something like a deferred as well. That's actually interesting. Is that more or less the same thing? Let's take a look. Puppeteer core has no okay, no export. Wait a second. Didn't it just import it because okay. I don't care. I don't really care. So let's see. This is from that's our type. Import that, please. Okay. Okay, so we now have a deferred, and we need a deferred over log type t. So we are essentially have something that is deferred and will return a log type t in the end. That makes sense, and we have an array of that. Yes, and in the beginning it is simply empty. Okay, so now every time we need to return something like that, we will simply put it into the queue and initiate something that will take the next element from the queue as soon as we have released mutex. Yeah, and then it will resolve it. Okay, that actually makes sense. So I guess we need to change this this acquire function a little. So this acquire function then would do something like call. We have a private function here called now, which is something like next in line or process queue. Yeah, process queue maybe. And process queue will return nothing. It will return void. It will simply work on the queue. So what we are doing here now is we are putting a new deferred into the queue. Okay, let's change that. Let's for now move that here because we will need it later on there in a different way. But for now, let's do something like const deferred equals create deferred. So we are okay. Create deferred. We are creating a deferred over log type t. And then we are going ahead and doing this queue push. We are just putting it in the to the end of the queue. We are putting the deferred there. Because this will be the next one that needs to be resolved when this acquire happens. And then we can now say, okay, do return the deferred's promise. Yeah, okay, that kind of makes sense. So now we simply do that, and before we actually return this promise, we will tell our implementation to process the queue. However, processing the queue will be kind of maybe asynchronous in the end. We will see. I think processing the queue needs to be asynchronous. Because it may simply do nothing, or is it needed to be asynchronous? What will happen here now, hopefully, is that it will detect there is something in the queue. It will see if it's the first one or the last one, if something is assigned or not, or anything, and then it will go ahead and kind of make everything happen that needs to happen in this situation. Yeah, okay. So how are we working here? So if we are processing the queue, first of all, if this queue dot length equals 0, then we simply return because then we have nothing to do. Otherwise, we check if a current lock is there. If we don't have a current lock, then we are going ahead and taking the current lock. So we are doing that. We are locking our mutex there. Then we are getting our queue entry. So this queue... Come on, I can never write queue. I don't know why. We are shifting out the first entry because we want to access it then from the front. We are pushing to the back and we are accessing from the front. So first in, first out. We are getting the queue entry and we are calling on this queue entry resolve with the lock that we just created and set. And it may be possibly undefined, yes, because you do not understand that I am quite sure because of this one here that It can't be undefined. It must be something there. Okay, so we are actually shifting out that entry. We are resolving that lock. And that is actually everything that needs to happen here. Yeah, that kind of makes sense. So now if something is already locked, acquire will be called, a default will be created, process Q will be called. It will not resolve the lock because there is already something else required. However, the default will be returned, the promise will be returned, and the acquire call will be in a kind of a waiting state. Okay, that makes sense. However, now, once it is unlocked, we need at the end to call this process Q again, because now we need to check if there is a next entry in line which now needs to get the lock. So every time then, if we are creating this queue, and every time something is released again, it will be looked up if there is another entry that wanted that lock, and then it is given the lock. So yeah, I hope this works, and actually this file doesn't have any errors. So maybe we just created a generic lock, a generic mutex implementation. So let's see. But by the way, I have no idea. I did not research if there is something like this out there. I'm quite sure somebody did implement something like that before. So, but I have no idea. I just wanted to think about this and to experiment with this thought of doing all of that interleaving asynchronous promisey stuff, because I thought, why not? Okay, so now we have that lock. We need some tests for it, I guess. So how do we usually create tests in Next.js? Let's quickly see. Next.js tests. Testing Next.js with Jest. Yeah, nice. So how do I actually need that? Example with Jest. You can create next step with the Next.js with Jest example to quickly get started. Yeah, I essentially want to, since there is Next.js no built-in configuration for Jest, to set up Jest, install Jest and the following packages as dev dependencies. Generic and basic Jest configuration file by running the following command. Okay, so is that actually what I want? Yeah, let's see. So we want this one using the are we actually latest version? Yeah, okay. So it seems to me that we need all of that. Install Jest and the following packages and dev dependencies. Yeah. Okay, so let's do that, and then we need npm init Jest at latest. Okay, so let's just do that. I think so. Let's see what happens if we do that. Even though I don't need to test React components of stuff like that. I just want to write a simple unit test for my library code, but okay, so I hope that this still works. Deprecated packages in all of that stuff, maybe not a good sign, but we will see. So now we had npm init Jest at latest, was it? Okay. Would you like to use Jest when running test script in package.json? Yes, I would like to. Would you like to use TypeScript for the configuration file? Okay, no is the default. Let's stay with the default. Choose the test environment that will be used for testing. I want Node. Do we want Jest to add coverage reports? I don't need to. Which provider should be used to instrument code for coverage? Didn't I just tell it I don't want it? Okay, but yeah, then let's use the default. Automatically clear mock calls, instances, contests, and results before every test. That's actually interesting. That would be something that I think would be nice. However, no is the default. I don't know why. Okay, let's stay with the default. Okay, so now we have just here Jest config, it seems. Okay, so yeah, okay, that's a lot of different stuff there, and yeah, mostly defaults, it seems. Okay, so now I should now be able to do something like npm run test, and it should actually run it and tell us that nothing was there. So it is actually looking for everything in a tests folder or everything called something spec. That's usually how I do it. I usually lay it besides my code and call it spec.ts and something like that. Okay, let's see if Jest, I think Jest has more or less the same syntax or style as Jasmine, more or less. So it should be able, I should maybe be able to do something like describe mutex, and we will see if this actually is how it is done. Should be instantiable. Let's write a really simple smoke test just to see if our testing framework actually works. Yeah, it cannot find the name describe. That already is at import node test. Yeah, maybe I'm not sure. Maybe I need to do something else there. Then I need to somehow import that because it doesn't seem to be global. But we'll see in a second. Let's do something like const mutex. No, mutex equals new mutex type something. Maybe you're just doing something like 423. That would be our value. It's just a number, and then we are simply asking expect mutex to be instance of mutex. And yeah, it doesn't find anything of that, but let's see what happens if I run that. Okay, it just tells me that mutex should be instantiable, mutex is not defined. So essentially it executed it and then got it loaded describe at it and stuff like that. So it should actually have understood that. However, it can't find it most likely because it doesn't know that this should be in the global context. However, I can import mutex, and now let's see if this test runs. Okay, it does not because cannot use import statement outside a module. Okay. So, okay. Just failed to parse a file. This happens when your code or its dependencies use no standard JavaScript syntax, or when Jest is not configured to support such syntax. Out of the box, Jest supports Babel, which will be used to transform your files into valid JS based on your Babel configuration. By default, node modules folder is ignored by transformers. Here's what you can do. Yeah, I kind of understand what's happening there, but I don't like what's happening there because I would have hoped that this would be automatically done by this setup here. Okay, let's see. Is there something like TypeScript in this page? There's an example. Okay, just with custom matchers. No, we don't want that. Inside just setup the following import. Good to know. Add a test script to package JSON. Creating your first test. Okay. Export default function page something, and then we want a page. Okay, so interesting actually, because describe and stuff like that is never imported anywhere. So the question is, this is a JSX. It's not a TypeScript file. So how would we do that with TypeScript? Maybe we can't, but that would be kind of strange. Okay, let's see. Next.js, Jest TypeScript. I just want to run that. There must be something like setup Next.js with TypeScript, Jest, and something. From when is that? From 2020. Okay, that's not really a new blog post. Let's maybe see. First of all, let's use Google for that, and then let's maybe tell it that we want only the last year. A complete guide, is Node.js run, and so on. Is TS node needed to run something? Yeah. Okay, there seems to be somebody who has exactly the same problem. TS node is required. Okay. Issue was before the configuration was saved as TS. So what I did to fix, rename to JS and change the content like. Okay, so maybe is there some config flag here? Coverage directory, test environment, JS DOM. Create just config. No. Okay. and tsjest to get jest working for Next.js. tsjest definitely did not work. The one works is using tsnode. You can install it via okay, but it didn't even, you need to have tsnode installed. To read TypeScript configuration files, Jest requires tsnode. Yeah, but TypeScript configuration files, I want a TypeScript test file. Okay. I mean, we could try to install tsnode, even though I like tsx better and nowadays and not tsnode, but we can actually try that. Save def tsnode, just to see if Jest then maybe executes that directly or something like that. We will see. Maybe now it just works. No, it does the same thing exactly. We need to somehow configure that. So yeah. That's actually kind of bad. I could just write a simple file and not using Jest. Maybe I should do that because we are just wasting time. I would have loved to actually use Jest here, but yeah, that's using TypeScript. Jest supports TypeScript by Babel. First, make sure to follow the instructions using Babel above. Next, install the Babel preset TypeScript. Okay, we need using Babel. Babel Jest. Okay. Yeah, but that seems to be unnecessarily complex just to execute some TypeScript tests in Next.js, which mostly is TypeScript anyway. So I don't understand why this does not work out of the box actually. Next.js, Jest, TypeScript. Mastering Jest in Next.js. Okay, this one is from the one from, oh no, it's newer, it's 2024. A complete guide for app router and TypeScript. Okay, so it's installing all kind of stuff here. Jest, testing libraries, React and stuff like that. Create a Jest configuration. Okay, so this is more or less the same that we have. It does more or less nothing. Perfect. Create a Jest setup.js. Do we maybe need that? I have no idea. So test is just calling, and then we are creating a tests folder. And then actually it is just using that. And it's using describe and it and something like that. And the system seems to be able to identify what it needs to do. And that's kind of weird, I think. So is it maybe they have this just setup something here, setup files after env. Do we need that? So what does this do? This specifies to run after the Jest environment is set up, put before tests are run, and it points to Jest setup and find where you can add global setup code for your tests. Okay, so what does this actually do? Is this explained? No, it's not, of course. Testing library Jest DOM. Yeah, okay, so maybe that's what provides us with all the things here. Let's maybe just... I think I didn't tell it to use JS DOM. I just told it to use V8 or Node or something like that. However, I would have thought that this would work. Okay, let's maybe just try it. They are importing that here as well again. So maybe we should just see what actually happens if we quickly import that. Last try. So let's see what happens if I do that. It's still what's actually in this. So okay, interface matches. That's actually not much. That's definitely not much. It gives us a couple of different matches or something like that. Testing library. What do we actually have here? JS DOM, React. Can we just do... No. It just will not work like that. And it seems to be unable to compile the the TypeScript parts. Okay, so let's not do this, even though I would have liked to do it like that. But let's do something else. Let's quickly create, to execute this in the correct context, let's maybe just create a new API controller. Why not? Yeah, I think we can do that. So let's quickly create something like test mutex. And then we will create a route TS in here. And wait, where did I route TS? Exactly. So, and now we are exporting a get function here, which takes a request, which we may not even need here, request, and it returns the next response. Of course, it returns a promise of a next response, and this will be a function, of course. And let's see, we will need to import. I would have liked to import that actually. So import next request and next response from next, I think. Come on. Did I respose? Oh, response. That's why it couldn't automatically import that. Next test, no. Okay, let's see where it would import that from. Add import from, oh, next server. Okay, yeah, kind of makes sense. Okay, so now we have that import there, and now we can simply return something like next response.json.hello world, something like that. What is it? What is the problem? Oh, yeah. Okay, now there is a different problem. The next response is missing the following properties from Puppeteer unknown, then catch finally something. Yeah, because this needs to be an async function, and then everything should be okay. Okay. So now we have this one. And now what I want to do is I want to actually create a mutex here. So mutex equals mutex, new mutex, mutex. Yeah, let's maybe just put a let's do a const value here, which is a value, which is an object with something in it like counter 0. And we then put that value into the mutex. So now we of course can access this value from the outside now because we still have it, but we don't want to do that. So let's see if we now can do that. So I want now a lock on this mutex, or let's call that lock 1. And we have an await on mutex dot lock dot acquire. There should be, isn't there? There should be an, wait, what? Oh, yeah. I need to import that from libmutex, of course. And now it should have an acquire function. Perfect. So acquire, and I want to acquire that mutex. And this one will now happen asynchronously. So so this one should actually directly acquire it. So we should be actually here and have the capability of saying, okay, I want to do something now with the value. So I could do lock1 value. Come on, value. Lock1 dot value. And I want to access the counter as it is stored by reference. I actually can do that. And I want to add one to it. I want to add to it. Okay, so this actually is possible. So now if I do something like how do I do that now in a separate thread? I think I need to do something like, okay, a separate asynchronous wait state. So let's do something like set immediate. In this immediate thingy here, I want to do something like lock1, const lock2 equals, and we need this as an asynchronous function to go into the background kind of. So await mutex dot acquire. So we have a second acquire there. And this should happen while it is still acquired or not. We will see in a second. It should happen while it is still acquired. We will make sure about that. So, and then once it has acquired it, it should go ahead and do lock2 dot lock2 dot value we could actually do something else. We could do timestamps here. That would actually make more sense to see what actually happens there. And this will be an object actually. So this one will do something like it will go into timestamps and it will set in timestamps lock1 1. And it will simply do a new date get is it time seconds? It is, I think, get time. Yeah. That gives us the milliseconds. However, we could not do get time, but get the UTC date. Yeah. Day of the month. No, I want, isn't there an ISO something format? I remember there is two ISO string, exactly. That would be kind of readable for us. So we are simply storing that there. Yeah, I'm fine with that. Okay, let's just do, that's any. Okay. And we want it like that. Okay, so now we have that. And now here we will go ahead and do the same thing with lock2. And we will say lock2 1. And then we will do something like set timeout here. Which should be able to do maybe here set another timestamp value. That would be lock1 2. And we will simply wait about a second here before doing that. And once we have done that, we will tell the lock1 to actually release. And once we did that, it should actually go here and execute the second one. And once we are finished here, we will simply return the let's do it the right way here. Let's do lock3 equals await. Oh, that's actually an interesting one, because now the question is, which of those locks will come first? This one or this one? Most likely this one, which would be kind of bad. That would be kind of bad. We will see. Let's see. But I think this will not work in this situation here, because we will be faster here than this mutex acquire. Wait, mutex acquire, and then we would do const value. Yeah, that's actually something that we should not do, but we need to release the thing. So const val. So what we do here now is, oh, then we never release that. That's kind of a problem actually. So it should it should return as a copy of that, or we should create a copy of that before releasing that. We definitely need to take that into account because we have a reference to that value. Yeah, that is a problem. That is a problem in the whole thinking about this mutex thingy. So even though we have made it hopefully quite robust, it still is a little. It can still be manipulated in a way that should not be possible there, but it is a problem. So maybe we can't really implement a really robust variant of that. I would need to think about that. So let's try that out then. So let's create that. Let's didn't I have something like a docker dev start exactly, which starts simply the npm thingy there, and then let's do a curl to http localhost 3000 slash API slash, how did I actually call it? Test mutex. And let's see what actually happens there. What do we get back? It should wait for a second, and then we get timestamps log1, timestamps log1 2 a second later, and then it is returned. And that's what I meant with when I do it that way. It will actually most likely not work out here because we need something that actually waits for this after we did that. So that's actually interesting. That's actually, we need we may need to do what we want to do here. We may need a deferred so that we actually do that in the right order. However, this one did not come between the log1 ones. So that's already kind of working, but we need to make sure that it is really working. So how will we actually do that? We could actually only do that by doing something like that would be a little bit crappy, but it will most likely work. We are simply awaiting a new promise here, which has a resolve function. So we are essentially creating our own delay function here now, which does a set timeout, which does nothing more than, or we can simply just really put directly resolve in here, and it will simply wait 2 seconds. So it will definitely wait longer than this one needs here. And then it should be able to acquire the corresponding log with the data after that one has run. So yeah, that could work. Let's see what happens now. And then if this now has the log2 in it as well, then it works like we expect it to. 2 seconds is a quite long time. Does it now work at all, or okay, something like that? There is something's wrong there. Did I do something wrong there? It's calling the resolve function. Or it should be calling the resolve function. Maybe it's not. I have no idea, actually. Oh, we are never... I guess now we are waiting here because we are essentially never releasing log2. Okay. That's of course a problem. We are never... Maybe we should create something like a timeout within the mutex or something like that to catch errors like that, because we simply forgot to call a release here. Yeah, that's kind of a problem. So let's restart that and let's do that again. Okay, so now we have log1, then a second later. Yes, we definitely have log2 here a second later, and then we should log1 there, the second one, and then we have log2. So this actually works. It is done in the right order, and the mutex actually does what it should do. Even though we can't 100% 100% see that this, or make sure that this works, because as long as we are accessing a reference, we need to make sure that we are not any longer being able to access that reference, or we are not accessing that reference any longer than we have we have it in our possession. So unfortunately, this here is kind of not the right thing to do, because I think if I have now something that would in the meantime be handled here, it could actually manipulate the value ref while I should no longer have access to it. That's actually, that's actually a little bit worrisome, because usually we want a mutex not only to read maybe, but mostly for some sort of manipulation there. So we can't implement a really stable mutex, I think. Nevertheless, this was a nice experiment, implementing something like this in TypeScript, and I think we have something that we might use now to create a mutex collection that we can then use to lock our pages. Or would it be even enough to maybe lock the array? No, it would not be enough. We need to lock every of the entries. Okay, that's actually interesting. So let me make a quick little pause there, and let me get something more to drink here. And then we will go ahead and experiment further by trying to create something that could be a mutex collection, which always gives you one unlocked element within your collection, or lets you wait until the next one is released again. That's what we essentially need for our page implementation there. And let's me make a quick break here, and then I will be back in a second, even though this will be a longer video, but I just wanted to play around with it and experiment with it, and we will see if you like it or not. Be back in a second. Hello and welcome back to this second part of the session. Actually, it is the third part, because in the second part I got carried away by repairing this test and Googling a little bit and finding out again why this jest setup did not work. Unfortunately, I did not have my microphone connected, so there is no audio, so I just left it out. I will quickly go over with you what I did to make this test run. So now we actually have a jest test running. It wasn't that complicated in the end. I just forgot some things during the installation that I didn't know anymore and that I didn't find while we were searching it in the first part. So what I actually did is I installed a couple of more, where was it? npm install a couple of more packages. First of all, I installed tsjest. That is something that I got out of a Stack Overflow post where somebody explained to install tsjest. I think we read it already in the session before here, in the hour before. And then what I did, and this is one of the essential things, I needed to install typesjest so that my TypeScript environment actually knows all the different describe and it and all the jest functionality there. And this jest environment node, I'm not 100% sure it was part of the command line, and I'm not even sure that it wasn't maybe already installed. However, we installed that, and then we needed to do one thing that is the other important thing here. So if I go into nvim and I open the jest config, we will see that I have now a transform entry here. And this transform entry actually tells the jest test runner to take everything that is TS or TSX and pipe it through tsjest to simply transform it to make it JavaScript for testing, and to use a specific TS config for that. And in this TS config jest.json, we are simply changing the module format to CommonJS again, so that actually we don't have this weird import problematics there. That is something that I need to experiment around with in the future, because I kind of don't want that. I want I want modules there. I want asynchronous imported modules, and this should work somehow. But I wanted to, or I did then stop there because now I have actually a running test environment, which might make things a little bit easier for us here. So if I now do npm run test, I'm not even sure. Can I do npm test? It seems I can do npm test or even tst, and it runs the test, and then it will actually run our mutex spec with which in turn is what you already saw before, the simple, no, that was the wrong file. Let's get the spec here, which is simply the instantiation test, the simple smoke test that we created. But as you can see now, my NeoVim here knows about this describe, for example, and it knows that it is a jest function and that is because of the installation of the types there. So that is essentially what I did to make this tests run. And now I think we should transfer over quickly our testing controller here to our mutex tests, because why not? We have written the code, so we can actually do that. And we should be able to do that maybe using clock mocks or something like that. I'm not 100% sure, but I would assume that Jest has something like that. So for now, let's just do it should lock or it should make acquire calls wait while still locked, something like that. And I think you can have asynchronous test functions. I would assume that you can. You usually can do that in Jasmine. I'm usually using Jasmine actually, or in most of my current projects at work, I'm using Jasmine. So I'm not that fluent in Jest, but they are mostly all the same. So maybe Jest has something like Jest clock, as well as no, it has not. So mock, let's quickly check them. Let's maybe first of all get our, what was it? It was mutex something route there. So let's maybe quickly get kind of the code that we wrote here out here, and put that into here. Yeah, it will of course not work perfectly here, but I guess we now can simply remove that that function here, so that whole route. So we don't need that file anymore. Okay, so let's take a look. What we actually want to do here, we want to have those timestamps. I'm not sure that we want timestamps actually. Let's maybe just put the order in there in which the things have been called, because we don't actually need the timestamps. So let's maybe make this a simple array, and we can then create this one, and then we can simply do something like called, and we push in the order in which it has been called, because that's essentially what's important for us to check. So we want that one. Then we want, let's change this one a little bit and do it via timeout as well. You will see in a second why. I want to do that in 100 milliseconds. So essentially before this one. And we will then do something like called.push, and we push in locked to 1 here. Let's see. So yes, and then we release it, and then we have another timeout, which is lock 1 again. It's a second later, and it will do called, and it will do push. And now I removed that one, so this one was lock 1, 2. Yeah, makes sense. And this can go, and this should be okay. Then we release it. And then we will do kind of another maybe thingy here. Or we do it with the same thing here. And then we get the log 3 acquired. And then we make an, is there an expect async here?
how do we actually do asynchronous expectations here? Or can we do we actually need to? No, we don't need to even. So what we can do here is we can do expect log3.value to equal an array with the entries log1, 1, log2, 1, and no, log1, 2, and log2, 1, actually. That's what should be in there, and then we can release that, and then we are finished. So now this test hopefully runs. Nevertheless, it will take at least 2 or 3 seconds. I'm not sure what time I'm waiting there. And okay, it does not. Interesting. So what's the problem there? Expected log. Oh, yeah. I just had to do something like log3 value dot called, didn't I? So now it should fix. It should work. However, we are really waiting that time there. Yeah. So and that's, I don't like that we are actually really waiting 2 seconds here. And the reason for that is that we are using actually timeouts. And I hope that there is something in Jest which is kind of the same thing that is in Jest documentation, that is in Jasmine, which allows us to actually mock the clock. So let's see if we can find something here about clock. Example, if you have a clock component that uses and so on, code API returns changing system clock. Can we actually set system time? Sets the current system time used by fake timers. Okay, so we need this faked timers actually, kind of. So the question is mock functions. Is there something like mock time or something like that? Okay, so fake timers. Enable fake timers. Okay. Now, for example, we enable fake timers by calling just use fake timers. This is replacing the original implementation of set timeout and other timeout functions. The timers can be restored to use real timers. Okay, use fake timers with use real timers. Nice. And then we should be able to somehow kind of tick forward in a way that we like to do there. Run all timers, timer game. Fast forward until all timers have been executed. Okay, that's not what I want to do. I just want to tick forward advanced timers by time. Yeah, that's something that I want to do. So advanced timers by time. Okay, so the functionality is called a little bit different, but it's essentially the same as in Jasmine. So what we want to do here is now we need how was it now called? Use fake timers and use real timers. Okay, so let's quickly do that and make our test a lot faster then. So what we will be doing here is we simply do before each, we are doing just use fake timers, and we are doing after each, just use real timers. So that's essentially what we want to do here. No, like that. And now we should be able, after we have all of those timeouts and stuff set, we will simply do, we can't easily do that then anymore. Yeah, we will see. We will, I guess we will kind of fix that in a second then, or change that. Yeah. Okay. So, so what we want to actually do here now is we want to kind of tick forward, or we actually want to run all timers, and I would assume that it runs them in the right order there. So run all timers, was it? What is that? Asynchronous run all timers. It also yields to the event loop, allowing any scheduled promise callbacks to execute before running the timers. Okay. That's actually most likely what I want to do, because we are using promisey and asynchronous stuff and so on in that. And then now we need to somehow, so this should already make it kind of, no, this will not make it 2 seconds faster or 1 second faster. Is there something like, we need an asynchronous expect. I'm quite sure there is something like expect asynchronous or async expect async matchers. Yes. How do we actually use asynchronous matches? So how does that work? Also supports async matches. Async matches return a promise, so to await the return. Yeah. Let's use an example, and so on and so on and so on. So, okay, that doesn't make. Okay, so we need to then create our own async matches or what? Custom matches API. This equals. Is there something like to be resolved or wait, resolves? So return expect. Okay, that doesn't make sense. How would that work? It could only work if it is asynchronous. So alternatively, you can use in combination with resolves. Okay, so it simply has that built in. In Jasmine, actually, you need to do something like expect async. Okay, so let me see. What I actually want to do here now is I want to have this thing here in a different, in another timeout, which would be here, which would be all of that code. Yes. And this will be an async timeout as well. And this one would be at the 2 seconds mark. And we will simply take this and put it down here. And then we would need to make sure that all of those ran, or at least that this one ran. I would like to ensure that. So we can easily do that. We don't even really need asynchronous. We don't even really need asynchronous expectations there. We should be able to do something like last timeout ran equals false, and we then do last timeout ran equals true, and we then just do here and expect last timeout. Come on, last timeout ran to be truthy. Yes. To be true, I definitely need to remap the control U command. Control U seems to do no. Control U actually goes up. So I'm unfortunately pressing yeah, that makes sense. Control U goes up page-wise. That's what I'm using all of the time. Okay, so I'm unfortunately during autocompletion I seem to not get the control key correctly, and Control Z is actually my autocompletion key. So that's why I'm sometimes removing what I wanted to autocomplete. That's kind of that's not so nice. I need to somehow fix that or to get the key better. So let's see how long it now takes. Okay, now the same tests take 11 milliseconds. There is somehow a setup time of kind of a second per test, which is kind of strange, or at least or overall or something like that. Let me try something. Let me quickly, please, do something like, let me copy this test a couple of times. I just want to see if this is a problem with the jest setup now, or if I did something wrong there, because it seems to me that even though the tests are really fast, that's kind of just the setup time for the tests then. We are at kind of 2 seconds, it seems, just to most likely compile the corresponding test code. So, okay, so now we have actually transferred our test code, and we don't need this route anymore. We have actually transferred our test code over into a real test code. which is quite nice. Okay, so let's see. So let's now go ahead and do what I actually wanted to do when I said we were making a little pause and then going on. I wanted to implement something that could be called maybe a mutex collection or something like that. So the idea here is that we actually want something like export class mutex collection. It's a collection over the type T, of course. And what we actually want to do here is we want to we want to have, first of all, we have some sort of public constructor. Okay, so and we have public constructor there, and we have something like private, and we have the collection here, which is simply an array of type T. Maybe we will change that. Maybe those need to be mutexes of type T, and we will see. We will see. And what we kind of want is we want some sort of public function to add something to the collection and to acquire something from the collection, I think. So what we want is something like add, and we want item T. Yeah, that makes sense, I think. So we have that one. Then we have something like acquire, and acquire will give you a promise with a lock over T. Yes. It will give you a lock, and maybe we'll need to put this mutex collection into the same file as the mutex to have access to all of the internal information and stuff. Nevertheless, this will be a lock of type T. Yes, we will get back a lock of type T, and maybe this is another lock than the one that we... Maybe we will have a collection like mutex lock implementation. That's not a problem, because this is an interface and we can have our own internal implementation, which actually makes sense. But yeah, we will see. We will return this... lock is not generic? Wait. It doesn't know about the lock, I think. Import lock from mutex? Come on. So, yeah. Okay, so that is something that we want to be able to do, to acquire. And this will be an async function, of course. And this should be actually the public interface there. So what we want to actually do is we want to be able to put elements in there. We want to be able to acquire them, and we might need, or not, we might not only, we most likely will need a function which actually returns the length. So this would simply return this dot collection dot length. Or let's call that size, just to contrast the fact that it is a function and not a property length, which we usually have in JavaScript. Okay, so now we have this collection. How would we actually implement something like what we are doing here currently? We need to keep track of the currently acquired items. However, actually we don't, do we? We can do that by essentially really by having those as mutexes. So then they are actually there, but then we would need to extend. Yeah. Okay. So let's quickly extend the mutex to be able to ask if it is currently locked, because we cannot do that. So I think what we would need to do is we have somewhere here acquire, and I would like to have another method there which simply tells me is acquired. And it returns a Boolean, because we can do that synchronously, and we can simply return this dot current log is not undefined, because if it's not undefined, then this thing is currently acquired. Okay, so now that we are able to check if it is acquired, this should actually be quite easy to implement, I hope. Let's see. So what we definitely will need here is a queue again. So this will be a queue of deferts of lock type T. Yes. And it will be an array, and it will be empty at first. Okay, so now how would this actually work? What we want to do here now is, if we add an item, we are simply doing this dot collection dot push new mutex over the item. We are simply creating a mutex, putting the item in it, and pushing that into the collection. Yeah, that should actually be it. We may need to do some this process queue here in the end, but that we will do when we implement that. Okay, so now we have the acquire function. So the acquire function actually goes then ahead and does this mostly the same than with our mutex before. So it would do something like const deferred equals create deferred over lock type T. And it would then, in the end, return the deferred promise here. And we would this dot queue dot push deferred. We would push the deferred into the queue, and then we would call process queue. So that essentially the next one, and this is not a function, this is a property, the next one that is available will be given out to this entry. The problem here is a little bit that and that is something where we need to think about in a second. We need to be informed about releases on our mutexes. So maybe we need to implement our own lock interface, because we need to be somehow informed about that. Yeah. Yeah, we will see. We will see. Let me write that down. To do, we need to call process queue when a mutex is, or if when a lock is released. Because if any lock is released, we need to process the queue again. Nevertheless, we can for now do something like process queue here, queue, which I can never write. And this one will actually go ahead and take a look if this queue.length equals 0, just return. Yeah, otherwise, we quickly check if we need to check our whole collection. So we need to check if there is something free to give out. So we could quickly create a function for that. Private find first released item, something like that. And it will return simply, it will return a mutex t, or it will return false. Yeah, I think we can do it like that. So we are simply doing const released items equal this.collection.filter, and we have a candidate here which is then checked. Candidate is acquired, and we want the ones that are not acquired actually. So we are simply filtering that, and if released items dot length equals 0, we simply return false, and otherwise we return released items 0 to the caller. Okay, so that is actually what we are doing here. So we are getting released item equals this find for, and that's, I pressed again the U key, find first released item, and if released item is not available, then we need to essentially, then we simply return. And otherwise we are returning, and we need to add a D here, we are returning the released item dot acquire. Wait, no, we are not. Otherwise, we are taking from the queue this queue dot shift. We are taking one out, and we are sure that there is something in there, because everything between here and here was synchronous, so we never left that processing chain there. And now we have a problem, because this acquiring could actually collide with another acquiring. That should normally not happen, but it could happen. So we need to kind of need to take care of that. So what we want to do now is we want to do something like So this acquire call is actually asynchronous, and it may queue, because we are not 100% sure that there is nothing else in the queuing there which hasn't been processed yet, but will be by the event loop. And it could happen at a later time. So it could be that something is before us in the event loop for acquiring this mutex. Usually this would not happen, and therefore it's not a problem. And even if it happens, we wouldn't simply be the next and would need to wait a little longer until this item is freed again. In reality, this should not really be a problem, but we need to handle it. So let's think about how we need to handle that. Because we have now taken out the deferred from the queue. So the question here is, if we should do it in this order, or if we should not do it in this order, but acquire the released item first, doing this in a separate asynchronous event loop chain, so that others could be handled in the meantime if we are waiting here. And then once we acquired this specific item, really acquired it, we are then going ahead and taking out something from the queue again. I think we need to do that this way. I think we need to do it this way. However, that could essentially create the case where we are creating more acquired items than actually are entries in the queue, because then it could race into the other direction there. So I think we need to kind of die one of the deaths. So I think what I want to do here is I want to take out this queue entry so that we have taken it out. Then I want to do released item acquire, and I don't want to await here now, because yeah, well, I could if process queue would be async. Yeah, I think I could do that. And if I don't call it then with an await, then it would simply background itself, kind of. So I could do const acquired, or that would be the lock released item acquire. Yes. So I need to await that. And then I would simply go ahead and resolve the queued entry with the lock. And this might race with another acquire call. We need to be aware of that. It should usually not happen, but it could. Therefore, the whole process queue function is asynchronous, but called in the background. Furthermore, we are removing the queue entry before calling the released item. Yeah, I don't like that, because I'm not 100% sure that it is, if I now call process queue really without the await, I'm not sure that it will be executed until this point before the next statement is at. Okay, that's not a good idea. That's really not a good idea, because I'm not 100% sure about the behavior here, because we need to execute all of that synchronously at the moment the process queue is called. So, okay, therefore, we do it in another way. We are moving this operation to the background. Before doing so, in order to be sure we are not double we are not trying to acquire more mutexes than we actually need due to races, because otherwise that could actually happen. So yeah, that is That is not nice, but it will need to work. So what we are going to do here now is we are doing it like that. We are doing it like this one will be the lock then, and then we can do it like that and like that. And doing it this way will simply move this operation into the background. Once this specific item, we now have kind of we kind of now selected this specific item of our collection to be used for this specific queue entry of our queue, which we took out here. And now this will happen, even though this released item might be acquired by something else in the meantime, if we are really unlucky. But then, yeah, we don't care. Then it will happen in the next cycle, and then this queue entry will be resolved, and then everything will be fine again. So yeah. Okay, this should work like that. So where do we have errors now? Property collection has no initializer. Yeah, that's true. Let's create an initializer here. Cannot find name deferred. Let's just import the deferred here. Do we have any other errors? We don't. So find for, okay, so essentially what we now need to do is we have to do this one. At the moment something is released, we need to have a way to essentially do the same, or to call our process queue after it has been released. And I'm not 100% sure how to actually do that, because in order to do that I would need to somehow, and we would need to somehow inject ourselves into the original lock. Yeah, I guess we can. We simply implement our own and call, and this one can aggregate the original mutex lock, and then we can, yeah, wait a second, that should actually work. So we are simply doing something like inner lock, exactly as we did kind of before, and this one implements lock T. And now I should be able to simply implement all of the interface values here. And what we are doing here is in the public constructor, constructor, we are taking the original lock, which is a lock T implementation itself. We don't even know, or we don't even want to know which specific implementation it is. So this should already work then. And now what we should be able to do is, first of all, I don't like it, even though it is the default, I don't like it if those do not have a specific visibility identifier there. So the value can simply be this original lock dot value, and we simply return that. We simply pass that through. The same with set value, return this dot original lock dot set value. There we go. And here we have this dot original lock dot release. We are calling the release function here, and here we are calling new value, of course. We are passing that, sure thing. And now we need to intercept that, or after we have actually released the original lock, we want to go ahead and trigger our queue processing. And that is where we actually need to maybe change the way we are doing that. So const process queue symbol equals symbol process queue. So we are doing it the same way than we did before, essentially. So we do process queue symbol, and This is then a public function, and we need to do then process Q symbol here. And we can remove that. And we actually, I'm not sure we did that in the other situation. We didn't need to do that in the other situation because it might not happen. We actually kind of need to do this again here. We might need to do this again here. I think what we want to do here is something like set immediate. This dot process. Come on, this process Q symbol. We kind of just need to trigger that again because there might be more than one Q entry waiting, and there might be still free slots to kind of give out to. Yeah, and we will do that with a set immediate to put it into the event cycle there as well and not do it directly. Yeah, that kind of makes sense, I hope. Okay, so find first released item. No, where is it? There. Then we should now be able to actually, we can take that in the constructor. We take private, we call that mutex as well. And this is a mutex collection over T then, so that we actually have that reference there. And now we should be able to do this mutex symbol, no, Q, process Q symbol, yes. And we simply call that after it has been released. And now, when we are actually giving out the lock here, we are doing new inner mutex this lock. Cannot find name inner mutex. Inner lock? Yes, inner lock. So essentially now we are actually annotating kind of our returned lock with our own so that we can actually pick up on the fact that it has been released. Is that actually everything that we need to do to make this work? Let's find out. Okay, let's do a mutex collection.spec.ts here. And let's see. So what we want to do is describe a mutex collection. Yeah, and let's do a really simple smoke test here first. So it should be instantiable. Okay, so let's do it like that, and let's simply see const collection equals new mutex collection, and expect collection to be instance of mutex collection. So essentially this should already ready run. Let's see. Why does it take so long? Why does it take so much time? I think because it needs to compile the files or something like that. I really think that 3 seconds to execute this little tests is a little strange. Can I do something like fdescribe here to only execute this test? Or does it? Okay, this is not the way that Jest does it, it seems. I have no idea, actually. So it's running them. Is it running them in parallel or something like that? I have no idea. Okay, so I would need to take a look at how to select a specific test. I don't really care. Okay, so essentially this test now runs. So it should should be able to take on items. Let's test our add method first. Okay, so const collection equals new mutex collection, and we can do collection.add, and we should maybe const item is just I don't care, it's just a string. It's just item 1, and we do item 1, and we do const item 2 equals item 2, and then we do a mutex collection over string actually, and we should add item 1 and collection add item 2. And in between we are checking the length. So we are doing expect collection.size to equal 1. And here it needs to be 2, and here it needs to be actually 0. So just a really simple smoke test to see if it can take some things there. Okay. So this seems to work as well. So let's quickly copy that. It should be able to acquire one available item. Let's start small here. So I think now this needs to be asynchronous, and I guess we only now want one item. So what we actually want now is const lock equals collection.acquire and await. And I hope there is a timeout in the test, because if this fails, we could be waiting a long time. But I'm quite sure there is a timeout. So, and then we would do something like expect lock.value to equal item 1. And then we should do lock release, just to be good citizens here. So does this work now? Okay, that worked as well. That worked as well. So I just realized I could have selected it differently. Okay, no idea. So it should acquire one available item and wait until released. So we have one item, and we will now do a lock 1. So we should maybe actually able to do that with set immediate. We need we need something then to wait on the completion of that, don't we? So so let's do the following. Const deferred equals create deferred. There might be a better way to do what I now do here, but I don't want to think too hard about that now, because I can simply do it like that. Await deferred promise. So we can wait here in the end, and now I can use asynchronous calls or asynchronous states here to actually do some stuff. So we want to set immediate, and we want the set immediate to actually the async to await a collection acquire. Then we want it to equal item 1, and it's called lock 1, of course, now. And then we don't want to release it, actually. And then we have another set immediate, which is async, which should do const log2 equals await. No, this is log2 promise collection dot acquire. Then then we want to expect that log2 promise not resolves not. Can I do not? It just resolves not. Is that actually? Can I do? Is that? Could I do something like that? Is that valid? No. Resolves not to, and then I need something to be. But I just want to. That's a little bit strange. Use resolves to unwrap the value of a fulfilled promise so any other matcher can be chained. If the promise is rejected, the assertion fails. Yeah, but the problem here that I see is that this is not. So, yeah, but I don't want it to be. Yeah, then it will wait. I don't want. That's a little tricky to do. I'm not sure how to do this with Jest. I actually would know how to do this with Jestmine. Okay, let's think about that if we actually really need that. What we want to make sure is that when we have this thing here acquired, the value is not given until, okay, if we do something like log2 await, what we want to make sure is that the next thing that we check here does not happen before this one is released. So how do we actually check that? We would kind of need to do that in another set immediate. So let log2 just do it like that, maybe. That's not really nice, but it could work. So so then we can do set immediate, another set immediate, which is async. And this one then could check expect log2 to be undefined, because it should not have been set. Yeah, that's actually that is a lock over a string or undefined. Lock is not generic? How is lock not generic? I think that there is something strange here. Import lock from mutex. Okay, I think it is thinking about some other lock. Maybe there is a lock in Node.js that I don't know. Okay, so now it should check that this is undefined, and then I should be able to do a set immediate again. which should then do something like, but then I would need log1. Yeah. I need to make those, to have those available outside. So let's make them available outside and then just set them here, because now I should be able to do something like log1.release. And now the log2 be set. I'm not 100% sure that this is already the case, or that we need to wait until the next set immediate to trigger another asynchronous event loop cycle. We will see. We will see. To be instance of mutex. No, of log. If this is even possible, log1 is possibly undefined. No, it's not. And then I will have something like expect log2 dot value to equal item 1. Yeah, it's kind of hard to test those asynchronous scenario thingies there. I really always struggle a little bit with those, especially, there is another error there. Import log conflicts with global value used in this file, so must be declared with a type-only import when isolated modules is enabled. Okay. Where am I using log as a non-type? Wait a second. What's that? That's actually... Oh, interesting. There is actually a lock within the secure context API of the DOM. Okay, that's... Okay, I guess we can just remove that. I guess we can just remove that. Nevertheless, we only need the log type there. Okay, so now let's see what happens with this test. It seems to be... Of course it hangs. Yeah, and it is it's running into a timeout because I never resolved that promise. So after I've done that, I should do deferred resolve, of course. Of course. Of course. Okay, it still runs into a timeout. The question is, where does it do that? So let's see how far it actually goes. So I guess it will never get there. So that's kind of interesting. Let's see. So is it going? Is it getting there? I hope that it gets there. So let's see. Okay, what's the problem here? Cannot read properties of undefined. Reading value in mutex collection spec 49. So yeah, that should actually then not... Yeah, makes sense. Okay, so let me quickly kind of comment those out and let's run the tests again and let's see. Okay, this works. Essentially, that's what we tested before. So the question is, if we do that, it will kind of wait, and the question is now, if we do something like, if we would have log1 dot release, if we would have released it here, would that at least have worked? Maybe our release function isn't working at all. So let's check if this would have worked. Okay, this worked. This would have worked. Okay, interesting. So now if I remove that there and I move it over here, so let's for now just check that and that. And let's maybe the intermediary step, let's ignore that. Let's see what now happens. I think now it passes. So I can actually do that. I can acquire it and then later on release it, and then everything is fine. But if I do, wait, what? What is if I do this expectation in between? Is the problem the to be undefined thingy there? Okay, then it hangs. Why the heck is this the problem? Why does this make the system hang? That's something I don't really understand. So let's do console log 2. I want to know what value that is in this moment. And of course, you are not telling me because you are in some sort of test environment. Yeah, sure thing. Thank you. Console log undefined. Wait a second, why is this not an error? If I'm calling value on undefined, shouldn't this be... Okay. I think I did not see that error. Okay, so it is essentially a problem with not having properly executed the chain as I had thought of in the beginning. So what we need to do here is we need to do this in another set immediate cycle in order to ensure that it has then properly called another event loop there. So now this should maybe work. Okay, so essentially our logic works. It's just that we need to do this in another cycle. Yeah, that's actually okay. This is actually working. So now let's kind of modify this one. It seems to me that our logic is working. The question is it working if we have more than one entry in the queue? So kind of parallel thing should give out first released item after waiting or something like that. So we now need 2 items. So we put item 1 and item 2 into the queue. So we now have this one and we want to put this one in there. And we have log 1 and log 2 and we will need a log 3. And first of all, we are locking log 1 and then we are locking log 2. And log 2 value is supposed to be item 2. Okay, so now we are actually, let's make this a little bit more interesting and doing some intermediate kind of release and reacquire work. So maybe we even have a log 4 here. Just to create a little bit more complex test, even though I think that what we implemented works. So now we have a set immediate here, which simply goes ahead and tells the system that log 2 is hereby released. Yeah, it's not. I'm quite certain it is not. Okay. So, oh, maybe it is. Unsure about that. We will see. We will see. Maybe it is. Maybe it can be at this point. Okay. So we are releasing log 2 and set immediate. We are then going ahead and taking log 3 equals await collection dot acquire. that's acquire. Come on. And we should then do something like lock expect lock 3 dot value to equal item 2 because we released item 2. Okay. And we need this one to be asynchronous. Come on. And I misspelled this one, expect. Okay. Then we want something like log 4 to await the collection of the next kind of free entry. We want log 4 we want log 4 to be undefined, yes, at this point. Then we are releasing log 1, that's essentially the same thing, and then we are assuming that log 4 is now equal to item 1, and then we should still call log 1 release log 3 release, no, log 4 release. And maybe we should even change that here and do and set immediate here again, just to be good citizens, because I am not 100% sure that we are not leaving something behind there that we should not leave behind. Okay, so maybe we should do it like that here as well, because we still have those things locked. And I don't want to leak any of the items there, even though this should not happen because we are actually destroying the whole object there at the end. Or at least the garbage collection should do that. But let's release them. Over-releasing them shouldn't be a problem. And let's do the same thing here. Let's do log 2 release, just to make sure, and log 3 release. Yeah, something like that. Okay. And now let's see if this actually works, because now we have 2 and yeah. Okay, so that actually works, and we are just getting back the next one which is available. And now I would like to actually test one last thing. What happens if I request one? It should give out newly added item to waiting. So what is if I have something like I have one item and I have only one in the collection and I have one lock, there we go. Yes, I have one lock that is acquired. I have another lock that is, and we should expect, we are actually expecting to wait here for lock 2 to be still expect log 2 to be undefined still at this point. And then we are going ahead, and I think we can remove all of that stuff. And we can remove those, and yes. And now we are doing set timeout. No, not set timeout, set immediate. Essentially, a set immediate is, I think, the same as the set timeout with the 0, but I'm not sure if that changed in the meantime. Okay. So what we now do is we are now adding another instance. We are now going ahead and telling the collection to actually add item 2. And as we do that, it should actually be given out to log 2 immediately, because log 2 is waiting there. So, and I think we might not have implemented that correctly yet. So set immediate expect log2 dot value to equal item 2, because this should now be there. Let's do an expect log2 not to be undefined. So let's see if this works, because I think it might not. Log cannot be properties of undefined. Expected received not to be undefined, it's undefined. As I said, I think we did not handle that correctly. So mutex collection, because I think, yes, in the add routine, we need to do this process queue. We need to actually call the queue processing after we have added a new item, because now there might be the possibility to actually handle that item. And then, yeah, it works. Okay, nice. I think we have just implemented a proper mutex collection for ourselves, which I kind of like it. It seems to be kind of stable. So what we could now do is we could now go ahead to our browser pool and maybe use that mutex collection here to make things even better for us. So I think what we can now do here is we have a browser and we do something like we have simply private collection, or we could call that pages, I think. And this is a mutex collection over the page, actually. Yes. Yes. And we have just a new mutex collection here. And of course, we need to import that. And then we can actually do the max pages stuff. But let's not get ahead of ourselves. So what we currently have here is a get browser, which will simply wait or give us the browser which we have initialized, or it will return. Okay. We have a require page. I think I would like to actually rename this to acquire. I have no idea why I called it require. Acquire is something that I think is more is nicer there. And I'm not even sure if I want to call it acquire page. I think it could just be called acquire, because it is the only thing that we can acquire from this browser pool. Okay. And maybe it should be called page pool. I think I will just rename it to page pool or something like that. Okay. So let's rethink everything that we actually have currently in here. Let's remove that. We will have then release here. And we don't need release anymore. We can completely we kind of can completely remove that. I'm not 100% sure. I think we need to do the same trick here with the wrapping of the mock, because we need to do something like that. Interesting. Yeah, we may still need that, but let's just comment that out. Okay. So what we now have is we need to now somehow implement this acquire, and this acquire should then be something like if this collection.size is less than and yeah, I said we'll do that later, but I think it is nice to do that directly now. Max page count, or max page count, max allocation count, we could call that. Yeah, I think that is a nice thing, and we maybe do 4 by default or something like that. And now if the size is less than this dot max allocation count. Then we can add another page to the mix. So the question is, do we pre-allocate all of those pages? I think that would kind of make sense. Or do we only allocate them if they are really needed? Because that would be a little bit harder. That would be a lot harder, actually. So I think we will simply pre-allocate. So if this is the case, then essentially, then this will only happen once, the first time you acquire. Okay, let's maybe do it that way, or let's maybe have something like something needs to call initialize on the browser pool. I'm not sure. There is no good way to, or no good position to actually do that outside of some sort of asynchronous dependency injection or initialization or something like that. So maybe we could do something like constructor. No, not in the constructor, but we could have something like private initialized, simply a flag, I guess, and it will be false initially. And then we would definitely have a browser here. We could assume we have a browser here. Yeah, if it's not, yeah. It's not great, but it is what it is. So then we would have an initialize method here, and it's simply private. Or we do something like ensure initialized. I think that is a good way to go. So I think that is actually a good way to go. I'm not even sure that we then really need this browser, but we can store it. Okay, so what we now do here is we are simply doing. Now this is then really easy. Okay, so then we simply do return this pages dot acquire, and we are. Oh yeah, this gives you a lock on a page. I'm sorry, of course it gives you a lock on a page. Of course it is, I need to import it from our mutex import lock from mutex. Maybe I should call it mutex lock or something like that, if that's actually a problem with the naming everywhere. So if this browser is not, the question is here another one now. If this is initialized, then just return. The problem is, wait a second, that's an asynchronous function. So we need to wait while we are initializing. Okay, that may be, that's a little bit, then we need something like private initializing. If this is not initialized, if this is initialized, then we are directly returning. If this is initialized, or this is initializing. Actually, I don't think we need that. We can actually just say that it is initialized. Yeah. Okay, then we return, and we are directly setting it, because in the end we don't really care, because our asynchronous collection will simply give out promises and then wait until the elements are there, the pages are there, and then it will give them out. So it will actually do the waiting for us. So we directly set it to be initialized because during the initialization itself, the mutex collection will simply give out promises on locks that are fulfilled automatically as the pages become available. This actually handles all the headaches about waiting until initialization is complete for us. That's actually really nice. Okay. So what we now do is we are assuming at this moment that we don't have a browser yet, so we are launching that. And then we are simply doing for something like let I equals 0 to I is less than this dot max allocation count, or we should not maybe then call it max allocation count, but allocation count, because we are now pre-allocating it. And we are doing E++ here. And then we will go ahead and simply allocate those pages, I guess. So what we will do then is this collection.add await browser dot what was it? Page, add page, create page. What was it? It's this browser. So new page. The property collection does not exist on browser pool pages, I called it, I think. Yes, pages I called it. So, and once we have done that, we are finished and it is initialized. Okay, so now we can do this dot ensure initialized. No, I'm not even sure that this needs to be. It needs to be asynchronous, but I'm not sure that we. Because we don't really want to. Do we want to await that? Yeah, I guess we can, because. Yeah, why not? It's not bad for us to do that. It needs to wait anyway. No, otherwise it could already take the first page ready. Like, it would actually be a little bit faster if we did not await that. Okay. Yeah, okay. So now we still have the releasing problem there. So we now need to get to be informed when it's released. So I think we will need to do the same trick that we did before with our and mutex collection there. I think we need to create an inner lock here that we can then actually use here as well and wrap around that stuff. Maybe I should actually do that in a more generic way. Yeah, I think that is okay like this. So it will be a browser pool. Now that we have here something like the pool, and it will give you all of the initial thingies and stuff. And once it's released, it will release the original lock. No, wait. It might not release it. It will need to take this original lock dot value dot and it is actually an inner lock over a page, and it implements lock page. And actually it simply implements log page. It is not something like, yeah. Okay, so it will do it like that, and this will be a page then, and this will be a page, and this will be a page. So this will actually really only work in this specific situation. So this original log.release, that is definitely what is called in the end. But before that, we will do go to about blank. And now we have a slight problem, because this function here is asynchronous. Damn it. And our release functionality until now is not asynchronous, which is quite good actually. And it is a little bit of a problem to make it asynchronous, I think. Not 100% sure about that. So how do we actually want to handle that? Do we simply ignore that, kind of? I don't think we actually can ignore that. I mean, we could just do something like that. That would be a little bit crude, because then the releasing would happen sometime later, but I don't think that would be a big problem. However, we would never catch an error there. So if this now fails, I think this go to about blank isn't a really hard requirement for our system to function correctly. So in the end, I think we might actually be able to get away with it in a way where we simply, if it errors, we simply ignore it, maybe. So let's do it maybe like that. Let's do an async. We call it directly here, and let's take this and put that there, and now we have an await this original value go to and so something, and then we will have that, and this now needs to be formatted a little bit differently. And what we want to do is we want to do a try here, and this will be in there, and then we will have a finally, which definitely always releases the log. The release function is not async. We cannot make it async easily. However, it is not a problem if the real release is happening a little later, as all acquires are async. Maybe I will make this async in the end. It kind of is. Maybe I need, but then I need to retrace all of our asynchronous thingies and handlings there and make sure that everything still works out. Maybe I will make that release call asynchronous as well. Maybe that would make sense actually, because it kind of is synchronous anyways. So, okay, therefore we simply call it in the background. However, due to this fact, we can't handle errors. The release needs to happen in the end, no matter what. The go-to of the page here is not life critical for our application. Therefore, we ignore its errors. Fix me. Make see if release can be made async in the mutex and mutex collection. Okay, so now we need to wrap that when we are actually giving back our pages. So what we are actually doing here is we need to then await the acquire here. Yes. Okay, so we are returning new inner lock. This await that one. And now it might already kind of work. So let's see if we now change that to, we are now acquiring from the browser pool a page. What we now need to do is we need to prefix every of these calls with a value because we are actually taking now we are having now the lock and not the page directly. So, but that isn't a problem. We can simply do that. And come on. So let's do that. And then we need to release it. Property release does not exist on type. Exactly, because now we are just doing page.release, which is kind of neater anyways. And this should actually be, maybe, we will see everything that we need to do to still have our screenshotting ability and now have refactored that in a way that we have a maximum sized render pool. So let's see, what do we have here? That's actually the one I think that I fired the last time. Exactly. So let's see what actually is the output of that. It should now actually spawn 4 pages in the background. Oh, it's a while loop. Okay, so it's now going and firing requests, and they are about 800 milliseconds there. Yes. So is it still doing the rendering okay? Yeah, it's still doing the rendering okay. That's the image there. And if I now do the same thing here again, maybe with bus PNG against something like example.com, it shouldn't be a lot slower. Okay, so it would actually be interesting to see what it actually gives out as a renderer. However, it has not become a lot smaller, so I would assume that it does that right. Let's do another one against example.com. That should essentially be more or less the same speed. Okay, and let's here do another one against my homepage. They are all more or less in the same speed range. They are around 800 to 900 milliseconds, if I see correctly. Yes. So I think we have now 4 processes there which are doing the rendering. And if we are now introducing a 5th or a 6th one, let's maybe try that. Then we should actually, against example.com, for example, then it should get slower because now it needs to interleave with other ones. Okay, it's not getting a lot slower there. So let's see if we do another one. Okay, now it's starting to take longer because now it has to interleave the requests with another process. It seems to me, at least. I mean, it's doing a lot of work within the Docker container, so maybe it's not even... Let me see how many... Oh, yes, Docker PS, let's go into that container here, Docker exec, into that container. No, I need a -IT here, please, and I want a bash there. And then I need a DNF install, what was it, PS misc or something like that? We figured that out the last time, yes. And that should give us a PS tree, which should let us see that, yeah, that there are, I think, 4 spawned. I can never really see that. We need to kind of restart things here. So yeah, let's maybe do that. Let's maybe stop that. Let's maybe stop that. Let's stop that, and that. And let's now just quickly restart that thing. It now has restarted the container, of course, which means I have to do docker ps here again. Take this, put it in here, and yes, I could, of course, isolate that via a simple bash and awk and stuff snippet and get that there and insert it, but it's not worth it. So dnf install ps misc, yes, and let's do a watch ps, or no, maybe not a watch, because like this we can see it. Okay, so now if I actually call all of those up, it should spawn all of those processes. It has spawned all of those processes, nice. And it should now have those 4 pages because we are actually pre-allocating. So it should not change. Nevertheless, what I'm now doing here, it should not change or allocate any more than those 4. So let's see what happens if I'm doing 6 requests in parallel again. It actually changed. There are some more processes. No, they are now gone again. So okay, maybe they just were some intermediate processes when it fetched something, or I don't know, some. But the essential, the page mount seems to be stable. We could maybe try to lock that out. So what I could do here is I could actually get the, let's go into here, and we can simply do something like console log. Or we could, no, we simply do, when we are adding them, we are simply doing console. No, we are not. We are going into this thing and doing a console log added item here. Added item. Now in collection, we have this dot collection dot length, something like that. And we can just do console log waiting for one getting available. Because in this situation we are waiting there, and otherwise console log one is available. Then we have one available directly. And then let's see if we now stop all of those curl request thingies here, those and those and those and those, and now simply restart this one. Then we should actually see, if we start one of those requests, we should actually see that it, yeah. That there is always one available, and it has item now in collection 0. That's a little bit. Oh yeah. I printed that before actually adding it. Okay, so that's okay. That's, yeah. So immediately after it was added, one was available and was given out, and that is exactly what we kind of wanted. So if I now do the other ones here, if I start this one and this one and this one, it should always have one available. There should never be waiting. So there are always available pages. Nice. So if I now start this one, it should not be available. There should be, waiting for one to get available, and then it is available, and then it is given out, and yeah. Okay, nice. And if I do this one, it should be the same, but only more waiting. Yeah, okay. So this is actually working exactly as we wanted it to work. So failed to connect because I simply killed the server there. So this is actually working exactly as we wanted it and implemented it. And we did it in a kind of a generic way. We discovered a couple of interesting things while actually trying this out and implementing that. And I hope you may have stayed with me in this thinking about mutexes and how we can lock stuff in JavaScript and how we can actually make things a little bit more safer by putting things behind visibility walls so that you cannot actually access them using symbols and stuff like that. And then there is, of course, a way to destroy this. We have already seen if we have a reference to a value and we are not directly using it, but simply assigning it to a variable and then releasing the lock, it is still possible to access the value by reference, and then we have broken everything. So that is, of course, a problem. I just could have taken the page out now and reused it for other stuff. I could not have stopped my implementation from doing that. Unfortunately, that isn't available or possible in JavaScript. At least I can't think of a way to do it. If you have an idea about that, please leave it in the comments. Would be interested. Maybe I will think on it a little bit as well. And otherwise, I found it quite interesting to actually implement something like this mocking in a more generic way, and then see that actually the implementation works for our use case quite nice. With regards to the release function, we need to take a look at that and make that asynchronous in the future. But I like this kind of experiments here. I like where this is going. I like thinking about that stuff and doing that together with you. And I hope you liked it as well, seeing me play around and think on this problem. And if you have gotten so far, please give the video a like, give it a thumbs up. If you have not yet subscribed, please subscribe, and please tell me if you like those new kind of format where I do longer videos on a specific topic and really go from the start of this experimentation to the end, and not like in this 30 to 50 minute range where I'm usually at. So if you like those longer videos, it would be great if you could give me a comment there if you have gotten so far, just so that I know that you would be interested in having longer videos in the future as well. I will not give up on the shorter format. You don't need to worry there, but I would like to know if you would be interested in longer videos as well. So I hope you had as much fun as I did, and I will of course push this into our web render experiment repository there, where we are currently playing around with stuff. And I hope to see you in the next one. So bye.